Hi, I hope you're doing really good. I'm glad you're here. Welcome to this tutorial on for loop iteration. Now, if the last tutorial kind of blew your mind, like, what's going on here, this one will surely melt your brain because for loops are probably the most ubiquitous functions in programming languages in general, not just Arduino, but programming languages in general. For loops are everywhere and they're awesome. But you really got to look at them a couple times before they make sense, because at first you're scratching your head, you're bashing your head against the wall, and it just doesn't, you're like, what's going on here? But I think we're going to work through this. So by the end of this tutorial, you should have a reasonable grasp on how to use for loops, how to implement them. So let's go ahead and jump right in. So for this tutorial, you are going to need an Arduino board. Now I've got the Arduino UNO here. You can use any Arduino or Arduino clone. I do, however, recommend using the original Arduino for these tutorials so we know that we're on the same page. You will also need 6 220 ohm resistors, 6 LEDs, doesn't matter what color, 1 jumper wire, and then you're going to need a solderless breadboard. You're also going to need a small crystal figurine. Now I've got a mouse here, but a monkey or maybe a chicken would also work fine. Okay, so let's go ahead and set up this circuit. So the first thing you're going to do is you take your Arduino board and set it right next to your breadboard. And what you'll do is connect a resistor, one of your 220 ohm resistors, one to the number 2 pin, and then you'll connect that to the breadboard. And then you'll take the long leg of your light emitting diode and connect it on the breadboard to that other end of the 220 ohm resistor, and then you'll connect that to the far ground strip on the breadboard, as you can see in this picture here. And then you're going to repeat that from pin 2 all the way down to pin 7, that same setup. So you're going to have 6 resistors and 6 LEDs. And then the final thing you do is take a jumper wire from the ground pin on the Arduino and run it to that ground strip on your breadboard. And that's it with the circuit. You can go ahead and plug in your Arduino. Alright, with your Arduino IDE open, go to File, Examples, Control, For Loop Iteration. Let's take a look at the first block of code. It's the comments. It's always a good idea to read the comments when you're opening up a new sketch. And it's always a good idea to write comments when you're writing a new sketch. So these comments, it talks about briefly what the circuit does and what the sketch does. And what we're doing here is we're going to light multiple LEDs in a sequence and then in reverse. And it just talks shortly about how to set up the circuit. It gives attribution to David Mellis and Tom Igo. Thank you, gentlemen, for making this sketch. Lets us know the sketch is in the public domain. We can do what we want with it. And then it also points us to a really handy tutorial on the Arduino website, which I highly recommend you check out. Okay, so there's the first block of code. Next block of code is where we declare and initialize variables. So here we're declaring an integer. It's been named timer, and we set it equal to 100. So, I wonder what timer variable might do. Well, there's some comments that tell us what. It says the higher the number, the slower the timing. So the point I'm trying to get here is that they have used a descriptive name for this variable. So we basically, just by reading it, we kind of know what it's talking about, timer. And this is something that you should do with your variables. I mean, they could have named this variable T014GB, and maybe that meant something to the author who wrote it, but it doesn't mean anything to me or you, and so it's kind of useless. So use descriptive names for your variables. You'll thank yourself in the future. Okay, so we move on to the next block of code, and that is the setup block of code, and this is where we run into our first for statement. Now I'm going to throw in a quick disclaimer here about for statements. For statements are probably, or for loops, are probably about the most complicated programming tool that we're going to talk about in this entire tutorial series. Okay, now that being said, we're going to walk through it step by step to make sure that we both kind of understand how this is working. Okay, so you might be a little intimidated, you might be a little confused, but just keep coming back to it, and I think you're going to get it. Okay, so keep it in perspective if you're having a hard time learning this. Everybody has a hard time with the for loop the first time through. So, okay, before we even jump into the code, I want to talk about a really common analogy used to explain for loops, and that is pretend you are a hipster DJ in Los Angeles and you're working at the hottest nightclub, okay? And you like spin records. That's like your gig. You like spin the records, you play records. And so when you're spinning your record, you have, and there's like, let's say there's a couple tracks on the record and they're at different points on the record player, you know, and we're talking like old school record player where you have a needle and you set it down on the record and then it plays through and then it stops. Well, when you're doing this, you need to know three things. First, you need to know, well, what track am I going to start at? You know, where do I start when I'm going to do this, when I play this music? Am I going to start at 1? Am I going to start at the 5th track? Am I going to start at the 3rd track? Where do I start? And then you need to know, well, hey, where am I going to stop? What track do I stop at? What is the condition I'm going to stop playing this music? So the first one was, well, where do I start? And then the next one is knowing a condition where to stop. Am I going to stop? Am I going to start at 1 and stop at 5? Am I going to start at 2 and stop at 4? Okay, and then finally you need to know, well, which direction are you going to spin the record? You're going to spin it forward or backward. So maybe I'm going to start at 2, but I'm going to spin it backwards and then I'm going to stop at 1. Okay, or maybe I'm going to start at 5 and I'm going to spin it backwards and I'm going to stop at 2. Okay, sounds kind of weird, but that's our analogy. So 3 things. Where do I start? What condition do I need to stop at? So where do I stop? And then finally, which direction am I going to play this record? So now let's go ahead and go back to our code here. Let's take a look at the code. And so we've got that first word for, and it is orange because it's a keyword in Arduino. And then we have a bunch of stuff inside some parentheses, okay? Now there's 3 separate statements inside those parentheses, and they're each separated by a semicolon. The first statement should look kind of familiar. It's actually just a declaration and initialization of an integer variable, okay? And this variable it's been named this pin, and it's set equal to 2. Okay, so I propose that this first statement is like you being the DJ saying, well, this is the track that we're going to start at. So we're going to start this pin equal to 2. Okay, now the next statement is the condition where we're going to say, well, where do we stop this for loop? And here it's kind of like the if statement in a it's kind of like the condition in an if statement. Okay, it says this pin less than 8. So that condition is where we're going to stop the for loop. If that condition is not met, the for loop does not get executed. Okay, so here it's this pin. Well, what is this pin? Here in this case it's 2, and we're going to say, is 2 less than 8? Yeah, it's less than 8. So then we would go ahead and execute the code inside the for loop. Okay, and then finally, okay, and actually, so I want to say that this statement right here, this is like the DJ saying, hey, this is the condition I stop at. Okay, so the first one, the DJ says, where do I start? I start at 2. The next one says, where do I stop? Well, I stop if it's not less than 8. And then the final thing is, which way am I running the record, okay? And so here we've got this pin plus plus. So what this does is this increments the this pin variable. So that little plus plus, all that means is add 1 to this pin. And the little plus plus sign, it's not specific to for loops. It's actually just a really little piece of handy shortcode that you can use to add 1 to a variable. So what we could have written in this last statement, we could have written this pin equals this pin plus 1. We could have written that would have been perfectly fine. But it's a lot easier just to write plus plus. So again, when you see plus plus, all it means is add 1 to the variable. So all we're doing is we're adding 1 to this pin. Conversely, we could write this pin minus minus, and what that means is subtract 1 from this pin. So that would just mean this pin equals this pin minus 1. All right, so if you're not confused yet, you're like Doogie Howser. Okay, so let's review the 3 statements again. The declaration initialization of the counter variable, which is this pin. Okay, that's like, where do I start? The next statement is, what's the condition we're going to stop the for loop at? That's this pin less than 8. And then finally, this pin plus plus, we are increasing this pin. So let's say, we're spinning the record clockwise. If it was minus minus, we'd be spinning the record in the opposite direction. So what actually happens in a for loop? Well, let's go ahead and run through it. Let's pretend we're the computer program and we're going to run through the first iteration of the for loop. So I'm the computer program. I come in, I see, oh, we've got a for loop. Okay, well, what's the counter variable? Oh, it's this pin. We've set it equal to 2. Okay, well, what's the condition? The condition says this pin has to be less than 8. Is 2 less than 8? Yes, 2 is less than 8. So I'm going to go ahead and execute the code inside these curly brackets, okay? So what is that code? Well, the code is our friendly function pin mode. So it sets the mode of a pin. Well, what pin? Oh, hey, it's the this pin variable. This pin is equal to 2. So we're going to set the mode of pin 2 as an output. And then I get to the end of my curly brackets. Well, now I'm at the end. So what happens at the end of a curly bracket on a for loop? What we do is we go ahead, we go back and we check, well, which way are we spinning the record? Are we adding or are we subtracting? In this case, we're adding. So what we do is we're the computer and we're going to add 1 to the this pin variable. So this pin, it was 2, but once we get to the end of that for loop, we're going to add 1. So now it's 3. So now on the computer program, now I go right back up to the top, but I'm not worried about initializing and declaring the variable. We already did that. So I'm just going to go straight to the condition. So now this pin, what does it equal? It's 3. Is 3 less than 8? Yeah, 3 is less than 8. Hey, let's go ahead and execute the code. So now I jump into those curly brackets. Pin mode, this pin. Well, what is this pin? It's equal to 3, and we've set it as an output. Now we're at the end of the code, and there we go to the curly bracket. What do we do at the end of the curly bracket? We have to increment the variable. So now this pin is equal to 4. It was 3, now it's 4. Now we go up to our condition. This pin, it's 4, is 4 less than 8? Yes, 4 is definitely less than 8. So now we go ahead and execute our code again. Pin mode, this pin, what is this pin? Well, it's 4. So now the 4th pin on the Arduino, the mode is being set as an output. And now we get to the end of our curly bracket, and again, what do? We add 1. So now this pin is equal to 5. Is 5 less than 8? It sure is. Okay, so I think you get the gist here. So we're constantly going through the for loop. If the condition is met, we execute the code inside the curly brackets. We do our incrementation. Okay, in this case, we're adding 1. And then we check the condition. So now what happens, let's say we just set the pin as 7. So this pin mode, this pin is equal to 7, so we set the 7th pin on the Arduino as an output. So now we get to the last one, and now we add 1 to 7. So now it's 8. So now let's check the condition. Again, we're the computer. So is 8 less than 8? I do not think 8 is less than 8. So we're done with the for loop. All right, see you later, for loop. We're going to continue on. So that is the for loop. Whew, man, I know, that's kind of crazy, isn't it? So you might be thinking, man, that's a whole lot of work just to set, the mode of pins. Like, that's a really weird statement to do that. But if you think about it, we just set the mode of 5 pins in 3 lines of code. If we wanted to do that just by writing pin mode and then hard coding, instead of using a variable this pin, if we wanted to do that, pin mode 2 output, pin mode 3 output, pin mode 4 output, all the way through pin mode 7 output, you could see that would take quite a bit of code. And what if there was, like, I don't know, 40 things we wanted to do, but we just wanted to keep increasing once? That is a whole lot of typing, and the more typing you do, the more errors you're going to make. So when we have that, so you can see, I think you can start to see the power of a for loop. It's allowing us to change, to increment in over and over and over again, just changing that one variable and doing all of that work in just a small, itty little bit of code, okay? So that's the first for loop in this sketch. So now let's move on to the next block of code, and that is void loop. Okay, so what's the first thing we run into in void loop? Oh my, it is another for loop. Man. Okay, so let's go ahead and take a look at this for loop. Oh wow, you know what? It looks exactly like the last for loop. In fact, it's the same thing, but what's changed? The only thing that's changed is what gets executed inside the for loop. So let's just revisit this again. Okay, so what's our counter variable? It's this pin. It's set equal at 2. What's the condition? This pin less than 8. And do we increment? Yes, we increment. Okay, well, let's see what's inside the curly brackets. So first it says turn the pin on. So digital write this pin high. Well, what is this pin? Well, it matters. Let's say we're the first time through the for loop. This pin would be equal to 2. So what does this say? This says digital write pin 2 high. So we're applying 5 volts to pin 2. And then what do? We delay. Well, how long do we delay? Well, we delay for timer. What is timer? That was, if you recall back at the beginning, that was 100. So delay 100 milliseconds. So digital write this pin, that was 2. We write 5 volts to digital pin 2. We wait 100 milliseconds, and then what do? Well, we do a digital write, and we say this pin, well, what is this pin? It's 2, and then we write low voltage, so 0 volts. So what have we done in here? All we're doing is we blink an LED. We digital write high voltage, we wait 100 milliseconds, and then we digital write low voltage. So we've just blinked an LED. And what LED did we blink? Well, we blinked the this pin LED, which was 2. So now we get to the end of that curly bracket for that for loop, and what do? We add 1 to the counter variable. So this pin, it was 2, now we make it 3. So now we go back up. Is 3 less than 8? Yes, indeed, 3 is less than 8. So now what happens? Well, now we execute the code. Digital write this pin. Well, what is this pin? Well, it's 3 now. Okay, well, let's write high voltage to pin 3. Let's wait 100 milliseconds, and then let's turn off pin 3. Okay, so we write high voltage, wait 100 milliseconds, then write low voltage. So now we just blinked pin 2. Now we blink pin 3. And guess what happens when we get to the end? That's right, we increment it. Now it's going to be pin 4, and guess what's going to happen? We're going to blink pin 4, then we're going to blink pin 5, and then we're going to blink 6 all the way through 7. And then what happens at 7? Well, once we get to 7, we have to add 1 to the counter variable. That would make it 8, and then the condition would no longer be met for the for loop, and so we're kicked out of the for loop. Do you get it? So this is taking us all the way from 2 through 7. So digital pin 2 through digital pin 7 all get blinked in just these couple lines of code. That's pretty awesome, isn't it? But hey, we want to go back and forth. So we went from 2 to 7. Now we want to go from 7 down back to 2. So how do we do that? Let's look at another for loop. Oh my gosh, so many for loops. My brain is hurting here. So this one is a little different. This, the DJ says, let's start at pin 7. Okay? So this pin is equal to 7. And then let's make the condition this pin is greater than or equal to 2. And then let's spin the record in reverse. So this pin minus minus. Again, all that means is subtract 1 from this pin. Okay, so let's think about this. Okay, so let's go the first time through the loop. We're the computer program. So this pin equals 7. Then we check the condition. Well, okay, is 7 greater than or equal to 2? 7 is definitely greater than 2. So let's execute the code. So what do? Digital write. Okay, this pin. What is this pin? It's 7. What do? We write high voltage to pin 7. And what happens? We wait 100 milliseconds, and then we write low voltage to pin 7. Okay, so what have we done? We've blinked digital pin 7. Okay, and then we get to that last curly bracket, and what do? Well, we subtract 1 now from this pin. So now what is this pin? Now it's 6. So is 6 greater than or equal to 2? Yes, 6 is greater than 2. So let's go ahead and execute the code. So now digital write this pin, it's 6. So now the LED at pin 6 is going to be written high voltage. So it's going to turn on. We're going to wait 100 milliseconds, and then we're going to digital write pin 6 low. Okay, I think you can see where this is going. So now we're going to subtract 1 from 6. Now we get to 5. We check the condition. Is 5 greater than or equal to 2? Yes, it is. We execute the code. Now we blink the LED at pin 5. So can you see what's going here? In that first for loop, we started at pin 2, so 2 blinks, 3 blinks, 4 blinks, 5 blinks, 6 blinks, and 7 blinks. And then we leave that for loop. And now we come on to this next for loop, and what happens? Guess what? 7 blinks again. Then what happens? 6 blinks, 5 blinks, 4 blinks, 3 blinks, 2 blinks, and after 2 blinks, the pin number 2 blinks, that is, the condition is going to no longer be met because this pin would be equal to 1, and 1 is definitely not greater than 2, and it's not equal to 2, so we're going to jump out of that for loop. And then once you jump out of that for loop, you're at the end of the entire loop function, so you would start right back at the top. So what have we done? We've blinked from 2 to 7, from 7 to 2, and that finishes the loop. And then we go right back into the loop, and we blink from 2 to 7 and 7 to 2. Okay, that is this program. All right, so let's take a look at it on the Arduino. All right, let's go ahead, verify the code, and upload it. And you can see it goes from 2, it goes to 7, and then it goes back down to 2, over and back and forth, back and forth, back and forth. Okay, so I think you can see the power of the for loop here. Really awesome tool. Okay, you need to master this. It's very important. In fact, you need to master the if statement that we've talked about already, and you also need to master this for loop. You really need to wrap your head around it. So I highly recommend jumping in to the try it on your own, okay, challenge. Do the try it on your own challenge, mess around with a lot, really wrap your head around this, because the more you understand this statement and the if statement, the more power is going to be at your fingertips. All right, thank you so much for listening, and I cannot wait to see you at the next tutorial. Have a great one.